Again, a pretty little flower. Well, here we go. What's the essential question for this video lesson? It's the second video, I guess, if you will, of Section 3, Chapter 10. And here's the essential question. How do you write the equation of the line that is tangent, there's a geometry word, to the circle at a given point? Now, you just know this, we already talked about this. This is the standard form of the equation of a circle if the center is the origin. We're not talking about writing the equation of a circle. We're talking about writing the equation of a line. And that means this, ladies and gentlemen, ba-bam. Good old slope-intercept form is what we're looking for. So this is the goal. We're writing the equation of a line that looks like this. So we got to find the slope, and we got to find the y-intercept, given a couple other things. Well, let's go talk about this word tangent. Let's go stroll down memory lane here. Go back to geometry. I know you love it. And let's talk about tangent. Okay, so here's the word tangent, and remember it dealt with circles. Now here's the definition. I'll just show you. It is a line, a tangent. It's a line that intersects a circle at exactly one point. Now, if I pull this over here and kind of show you, here we go. This right here is a line that intersects the circle at exactly one point. Problem is, that by definition is not a tangent. If I draw a line like this that goes through the circle, just like this one actually went in the circle, that is not a tangent as well, because it intersects two different places. That, by the way, is called a secant, in case you remember. Here's what a tangent is. It's an actual line. I'll do it this way. It's a line that intersects the circle at one point, so wherever it is, but it is outside the circle, bam, like that right there. That's a tangent line. So it doesn't go in the circle. It intersects at only one little spot right there. Whoops, sorry. That little spot right there is the actual spot. The spot in which it intersects is called the, speak, would you, Mr. Monitor? That point right there, and you should write this down along with the actual definition. If you haven't already, write it down. That point right there is called the point of tangency. This, remember, is not, I'll erase that, whoops. That right there is not, beep, no, that is not a tangent, nor is this one, no. But this one up here is, and I can move this around, I can move it over here if I wanted to, right there, great. That is a tangent, because it intersects at exactly one point. That point right there is called the point of tangency. Now, if you recall, there was a postulate in geometry called the tangent postulate that said if you have a tangent line, it is, I'll finish it out here, and you need to write this down, it is perpendicular to the radius drawn to the point of contact. The point of contact is the same thing as the point of tangency. That's point B. So if I draw this radius right here from this center of the circle to that, this tangent postulate said, oh by golly, then super duper looper, it is perpendicular. That is extremely crucial for what we're going to talk about. Because here's the whole idea of this section, or this video lesson. We're finding the equation of this line right there, the tangent line that goes through one particular point, which is going to be the point of contact. So if I throw this thing on a grid like such, and I show the x and y axis, oh looky there. So it's going through a specific point. That point, I'll just draw it for you, happens to be right there, and that point is -4, -2. That's the point of contact of which the circle goes through and the tangent line goes through. So our goal is to find y equals mx plus b for this tangent line right there. And we only have one point, and that point is -4, 2. Whoops, sorry, -4, -2. Lovely. Let's do it. Here we go. So my first task is going to be this. I need to find the slope and then the y-intercept. So let's find the slope first. Now keep in mind, we're finding the slope. Let me change color. We're finding the slope of this red line right there, the tangent line. We're finding the slope of that thing. Okay. Well, here's the point. Well, not the point. Here's the problem. I only got one point, again, on the tangent line. But if I look at the radius, I do have the origin, that's 0, 0, and I do have the other point given to me out there of -4, -2. So, let's find the slope of this radius, shall we? If I do that, here's what I get. Well, actually, let's back up a second. Hold on. Or just forget that this is here. So here's what we'll do. So I'm going to take this y and this y and take and subtract them if I'm talking about slope formula. So it's y2 minus y1 over x2 minus x1. So, well, I'll do it this way. So go, yeah, x2 minus x1. So we'll go -4 minus 0. So when I solve that, that gives me -2 over -4. If I can move this over. Nope. So I'll keep going. So that means that gives me a slope of +1, yeah, over 2. So 1/2. Lovely. Now, keep in mind, negative over negative cancels. That's why I got the slope of 1/2. But here's the Scooby-Doo. Remember, that, ladies and gentlemen, is the slope of the radius. I don't want the equation where I'm plugging in the slope here for the radius. I want the slope of the tangent line. Oh, wait a minute. It's perpendicular to the radius. So, the slope then of that guy is going to be, since it's perpendicular, the opposite reciprocal of the radius. Oh yeah. So I'll take the opposite reciprocal of this guy right there. So then that means the perpendicular slope, which is the one that I want for the tangent line, is going to be -2. So I take that -2, wonderful, and I plug it in right there. Boom. So that means I have y equals -2x plus b. Sweet. All I need now is the b. So I'm going to have to write some of this so I get more room, but I hope you write this down because here's where we are. We are at y equals -2 plus b. Okay? So remember, let me get back here where I was. Sorry, I had to erase all that. So this again is -4, -2. Lovely. Bam. Okay, and I just found the slope of this thing to be -2. That's cool. So that was the slope. So remember, I am at y equals -2x plus b. Well, ladies and gentlemen, how do I find the y-intercept? Oh, I know. Why don't I just take and plug in y and x? I have a point right here on the line. So this is my y, and that's my x. So I take those, and I'll plug them into the formula, and I will, well, not the formula, this equation, and solve it for b. And then plug that b back in here, and bada bing, bada boom, I be done. So I take the -2, put it in for y, so -2 goes there. The -4 is going to go in here for the x, so it's -2 times -4. Yeah, that's cool. And then that's all plus b. Lovely. So when I do this, this here gives me +8. Okay. And that equals still -2. Lovely. Plus b. When I subtract 8 from both sides, subtract 8 here, subtract 8 here, that gives me a y-intercept of -10. So, ladies and gentlemen, congratulations. We've just found the equation of this tangent line when I plug this guy in for b right here. So let me change colors. I'm going to make it green. So that means my answer is y equals the equation of this line, -2x minus 10. Why minus 10? Because it's a -10. You could do plus -10 if you want. But ladies and gentlemen, congratulations. There is the equation of this particular tangent line. Now I'm going to show you this. This is kind of cool. So the slope certainly is -2. You can look at it. It goes down 2 over 1, down 2 over 1, down 2 over 1. But I'm going to erase all this, and I'm going to move this all up, and you're going to see this tangent line actually does cross exactly at -10. Watch this. Get rid of that. If I can grab a hold of this stuff, that'd be cool. I think I can. I'll move this all up. Wait, can I do it? Come on, work. Beep. So I'm going to move this up, and check this out. You can see right there, the actual tangent line goes right through -10. That is your y-intercept. That's really cool. Okay, so there's one example, a pretty lengthy one, but let's go do another one quick, and we'll be done. Awesome, let's go find the tangent line. equation of the tangent line. So just to quickly revisit the essential question, this is, remember, is what we're doing. Writing the equation of the line that's tangent to the circle at a given point. So here's an example. Last example, write in your notes. For sure, write an equation, just did it, of the line that is tangent to the circle, x squared plus y squared equals 10. Now here's the scoop. You're going to have to actually do this. You don't necessarily have to draw it, but here's the deal. This is the standard form of an equation, but I had to find the radius length. How did I do that? Well, you take this thing right there, the 10, and you square root it. When I square rooted 10 to give me the radius length, because remember, this is really the same thing as r squared up there with the radius length. So to find what that is, just kind of convert it back, I got to square root it. That gives me, I should approximate this, approximate 3.16. That's the actual radius length. So 3.16, that's why it's at 3.16, use 3.16, 3.16, 3.16. Okay? But the given point is 1, 3. So there's 1, 3. So my tangent line, the red line, that's my tangent line. That's my whole goal. I'm trying to find the equation y equals mx plus b. That's what I'm looking for right there for the red line. Okay, so let's do this. Okay, so first things first, since I'm trying to find the equation of this red line, let's find the slope of the radius, because remember, it's perpendicular to my tangent line. So I got to find this slope first. I have this point up here again given, 1, 3. That's great. So this point here, the point of contact is 1, 3. That's my origin. So when I use slope to do that, I would do y2 minus y1. Wonderful. And then x2 minus x1. So that gives me a slope of positive 3 over 1, which makes sense. That's cool. But that's not the slope I need in this y equals mx plus b for the tangent line. That's not the slope, guys, right there that I need. The slope that I need is the opposite reciprocal of this radius. So I got to take the opposite reciprocal of this radius, which gives me perpendicular slope. The opposite reciprocal is negative 1/3. Yummy. So that's gross. So negative 1/3 is the slope that I'm going to have to use to plug in here to the equation. Sweet. So here's where we are. We have y equals negative 1/3 x plus b. Where did 1/3 come? Where did negative 1/3 come from? Remember again, that's the perpendicular slope I needed for the tangent line. So now I have to find what the y-intercept is. Well, that's a weird one. Look at that. Wow. That's not going to be a nice number. You can see it's somewhere between 3 and 4. Well, let's see what it turns out to be. We have to take this point again up here. I can't even see that, but it's up here where my mouse is. And I take the 3 and put it in for the y, like this. And I take the 1 and I put it in for the x. So it's negative 1/3 times 1. Okay, we got a little fraction action here. Love it. I love it. Fraction action. So negative 1/3 times 1 gives me this 3 equals negative 1/3. That's pretty simple. How do I solve this thing for b? Well, what I'm going to have to do is this. I change colors if I can. I probably can. We'll make it purple. So I need to add 1/3. It really doesn't look any different color. I need to add over here 1/3. Okay, so when I take 1/3 and add it to 3, I got to convert this so it has the same denominator. That's the same thing as, convert's the wrong word, I have to write an equivalent fraction. I'm going to get 9/3, that's the same thing. So now I can combine them. 9 plus 1 gives me 10. The denominators stay the same. So that means my y-intercept is actually 10/3. Now if you did that as a decimal, that is the same thing, equivalent to 3.3 repeating. Lovely. But by the way, that should make sense because look, that's about 3 1/3 up there. That's cool. So how do I write this answer? Well, keep in mind what my answer is. I'm looking for the equation of the line. So I'm almost done. I just got to take this thing now, the y-intercept, and plug it back in here. And then I'm finished. So let's write it. Here we go. So the equation of my tangent line, that is perpendicular to my point of contact here, the radius length, whatever, that whole tangent line, is y equals negative 1/3 x plus 10 thirds. And if you want to write it as a decimal, I guess you can. That's cool. But this right here, ladies and gentlemen, yeah, buddy, whoa. That right there is my final answer. So I just want to make sure you saw an example of which they all don't come out to be a nice, perfect little world answer. No. Sometimes they come out to be fractions. It's okay. But go back and study these things because you just learned a pretty cool concept. We'll see you in class later.